So I wanted to make a quick video showing you something I'm working on, something I finished. It's a little dyno project, a little dyno tuning project. What I got here is, this is a Superflow dyno. We just did a dyno run on a motorcycle. And this thing, what it does is, if you're familiar with the dyno, it saves, records horsepower and air fuel ratio and tuning and things like that whenever you're doing dyno work. So on this particular run, I actually ran it. It's a GSX-R 1000. I ran it on the dyno, and we've just recorded some data out of it. We've recorded our air-fuel ratio. And I won't get into the explanation of what air-fuel ratio is. I'm hoping that you already know what that is. But I hope, and also the understanding that the dyno will, capture that information while the motor's running and being run at wide open throttle. So what it does is the dyno calculates horsepower and torque. These are the two horsepower. This is the horsepower channel of all these values. This is the engine speed as it's running up through the RPMs. It's 10,000, 11,000, 13,000, 15,000. This is the power that it's making for every RPM point. This is the torque that it's making for every RPM point, respectively. So, and also, this is the air-fuel ratio that it's recording at the same time. So whenever it's at, let's say, 12,000 RPMs, its air-fuel ratio currently at that spot is 13.6 to 1 air-fuel ratio. So what happens is a motor likes to run and will make its best power at certain air-fuel ratios. This particular motor will probably make its best power and run its best around 12.8 to 1 air-fuel ratio. Well, currently it's too lean. It's 13.6. We need to richen it up to get to 12.8 air-fuel ratio. So what I normally have to do is I'm fumbling around with a laptop, a tuning laptop, and a calculator, or my phone, the calculator app on my phone, to do this calculation. And it's not just a straightforward, just simple one operation. You have to do a little bit of math to figure out what you need to get to 12.8 to 1. So how do you do that? So if I was tuning this bike right now, which we're fooling around with, this is the fuel map from the kit ECU from it. So it has RPMs across the top. This is the RPMs. This is the throttle position. And these are the values for the fuel values that it's using while it's running. So as you're accelerating wide open throttle on the dyno, it's coming across here and using these values across the bottom as its fuel values. So at 12,000 RPMs, it's using 7.81. That value right there is 7.81. That's the value that the ECU comes and looks at the map and says, okay, I need to inject this much fuel according to this value, and it'll inject more or less. The bigger the number, the more fuel. The smaller the number, the less fuel. So right here, it's injecting more fuel. Over here, it's injecting a little bit less. It's 7.03, and it's continuing to use this. And then even at the end, it's injecting even less at 6.25. So what I need to do is, right now, the bike's too lean. I need to add more fuel in this section right here, as you were recorded at 13.6 at 12,000 RPMs. So how do I do that quickly? Well, I have an app. I just made this app for the Apple App Store and just got done coding it, and it just was released this morning. It's available on the App Store. You can download it and use it for a small fee. But anyway, here's how it works. So you enter in some basic values. Here's my basic value right here. My air fuel for best power, that's my target. That's 12.8. That's my target AFR. So if I put in 12.8, whoop. I'm doing this while I'm looking at the camera. Okay, so they're entering in 12.8. So now I need to enter in my map value. Now that's the value over here, this 7.81. If I take this map value, clear that, enter in fuel map, 7.81. And now what I need to do is I need to enter in my current logged air fuel ratio. That's the value I just showed you on the dyno that it recorded while it was running. So it's 13.6. 13.6. So now I've entered in the important stuff, press calculate. So here's what happens. It calculates for you what you need to make your map value, your new map value at. So right now it was at 7.81, which I showed you over here. It was 7.81. My new value needs to be 8.3. So that's a 6% change. I need to richen up the fuel tuning by 6%. You can see up here at the top, it says multiply your fuel map. This is just a reference to show you what it's doing. It says multiply your map value by 1.06, which is 6%. And at the percent value of the change is 6.2, technically. If you wanted to get more decimals in there, it's 6.2%. But it's that simple. That's all you do. And then you take that value and you enter it into here, replace that 7.81 with the new value of 8.3, and then you run the vehicle again. You run the bike on the dyno or whatever, the car, anything like that, and you keep repeating this process until you get your fuel tuning to where your air-fuel ratio is correct across the entire RPM range. So it's really fast. I made this thing so that I really wanted something that I didn't have to fiddle around with multiple calculations on a calculator, and something that was really handy and quick with my thumb right in this region right here, so that I wasn't making massive movements when I'm trying to do this and I can get through it quickly. It's made for, speed, really. A lot of time is wasted, fiddling around with little things, and I wanted to be as efficient as possible with this. So there's a little info button right here. If you press this little info button, it tells you how to use it. There's little directions there, and that's it. It's really basic. It works exceptionally well and is very fast, and you don't, like I said, you're not fumbling around with a regular calculator. The other thing that, let's say, this is for car guys. I do a lot of car dyno tuning as well too. Let's say you're running a Holley carburetor, and you have, let's say you're running a Holley 600 and you got a 58 main jet in it, and your target air fuel ratio is 12.8. This is a Chevy 350 or whatever, anything like that, big block, whoever, and you do a run on the dyno, and you come up at 14:1. Press calculate. Your new main jet size is now going to be a 63, which is closer to a 62, or I don't know if they make an increment of 63, but you get the idea. You need to make like a 10%, a 9% jet change. So you go up 9% in your jet size and run it again, and you'll be closer to air fuel ratio. So there you go. It's available on the App Store. Let me reload this thing. I'll show you the start screen. This is the logo, what you're going to look for on the App Store. When it starts up, there it is. Fox Performance app. Thanks for watching. Go check it out.